So welcome to lesson 4 from my refresher course. Today we're going to be talking about coordinate geometry. Um, so we'll look at lines and slopes and equations and things like this. Okay. Um, so when we do coordinate geometry, we're going to have this page here in the tables, right? And it's a little bit of it can lure us into a sort of a false sense of security, right? That we kind of think, okay, well, we have all the formulas, so this section is going to be easier. And in particular, what they're going to do is they're going to give you questions that require you to use maybe one or two of these formulas, or you know, um, maybe you'll have to do a little bit of work first to sort of prepare the question, so you can then apply one of these formulas. Okay. So that's how this section is. You have to do a little bit. It's a bit more creative. You have to do a lot more kind of thinking in this a topic than you have to do in others, right? So it's you can't just go ahead and directly apply the formulas. Okay, so we're going to just do a few questions to start off with, and these are just warm-up questions. So this is just to get you thinking. Um, So the first one, you have a line that goes from 0, 0. So let me start drawing. So you got a line that goes from 0, 0 to the point 2, 4. So 1, 2, 1, 2, 3, 4. There it is up there. And this is the line. And it says it's a slope of 2. Okay, so to get the slope, we're like the rise over the run. So it goes up by 4 and it goes across by 2. So that's 2. So this one is correct. Okay, the midpoint of 2, 6, and 4, 10. Well, if I take 2 and I take 4, and what's halfway in between 2 and 4? Well, it's 3, and then halfway between 6 and 10 is 8. So that's also correct. And the distance between, 0, 0 and 3, 4. So if I go 0, 0 to 1, 2, 3, 1, 2, 3, 4, that point there. So this is 3, 4, and this is like 0, 0. Now they're saying that it's 6. Okay, is it 6? Well, the run is 3, the rise is 4, and we actually have a right angle triangle. So 3 squared plus 4 squared is equal to 5 squared, right? Not 6. So this is wrong. And then a line perpendicular to the line 3 has a slope of minus 1/3. Well, if we have two lines that are perpendicular to each other, and this one sort of perpendicular, and this is M1, and this is like, let's say this is M1 and this is M2. And let's say M1 is equal to 3. Well, we're actually going to write that as 3 over 1. And then we're going to say like M2 is equal to, you invert that, and then you make it minus. What we need is that M1 times M2 gives us minus 1. And it's simple. Basically, like if you have, for example, a fraction like 7 over 8, what would we have to multiply by 7 over 8 to get a 1? Well, it's the same thing, just flipped upside down. So the 8 cancel with the 8 and the 7 cancel with the 7. And then if we wanted to get like a minus here, then one of them would have to be minus. Okay, so all you're doing if you're getting a perpendicular slope is flip the thing upside down and get and then add a minus sign. Okay, so these are just some normal questions. And what we're going to say, so the key idea, is with coordinate geometry, we have these pictures, and we're going to turn these pictures into like numbers and equations. So we're going to make this bridge between this sort of graphical, world with x-axis and y-axis with circles and lines and things like this. And then we're going to connect that to algebra, like to equations like this, so we can work out things like how far 2 points are away, like what the area of a triangle is, what's the slope, and so on, right? Okay, so what I want to do is I want to spend a few minutes going through the. I want to spend a few minutes going through these formulas here. So let's take this. Let's take this one here to begin with, right? So slope formula. Like, where does this come from? Okay, so if we have if we have 2 points like here, and that's my like x1, y1, and this is my x2, y2, the slope is the rise over the run, right? So it's basically like what we're doing is we're going from here and we're going up to here. And as we go from here, we want to know how steep we are, like how much we're sort of going up or down, right? Like, and the way that we do that is we compare like the step size vertically, which we call the rise. So we're going to take that's the rise. And then we look at the horizontal one. This is the run. Okay, and we get the fraction. So this is telling you how much are we going up in comparison to how much we're going across, right? So you could go up, like you'd say, is the mountain steep, right? Well, you could say, well, it is like 2 kilometers high, but it takes me 10 kilometers to get to the top. Or it only takes me 1 kilometer to get to the top, in which case it is a tall mountain. So it's not just enough to say how much you go up. It's how much you go up into comparison to how much you go across. So how quickly you go up or down. That's what tells you how steep something is. So that's why this makes sense. Now what we're going to do is we're going to say that this side here, the run is actually, this is x1 and x2. The run is actually x2 minus x1. The rise is actually y2 minus y1. So that's y2 minus y1 over x2 minus x1. And if we consider for this line here, like we just take not a fixed, like saying x1, y1 means we're sort of fixing the point, right? Saying x2, y2 means we're fixing the point. So these are fixed points. But what if we just had a general point here, not like y2, x2, but just another, then this formula would be y minus y1 over x minus x1. Okay. All it's saying is like it doesn't matter where we set that next point. Like if that point is there, this is our slope. If that point is there, like this is our slope. Our slope is always the same. The length of whatever, the distance doesn't stay the same, but the direction, right? How much it doesn't matter because it's a line, because you never change direction, right? So the slope would be the same no matter what. And now we just multiply across, like x minus x1 goes across, m times is equal to y minus y1. This is the equation of a line. And now what we can do is we can multiply everything out. So y minus y1 is equal to m times x minus m x1. And when we get everything all over into the right-hand side, we'll have this other form, which is y is equal to mx plus c. So if we have a look at the equation, so the equation of a line, we have this form, but we have a second form. This form is good for finding the equation of a line if you have, a point and the slope. And the second one is good for, if we're given this, we're able to read that, whatever number, like y is equal to 2x plus 5, that this one here, the number in front of the x, that coefficient is the slope, and the other coefficient is where it intersects the y-axis. So it might be like this: 1, 2, 3, 4, 5, with a slope equal to 2. So that might be our line then, right? We can quickly get get what we need to draw the line if we represent it in this form. Okay, so the next formula we want to talk about is the distance formula. So again, if we take like we're going to look at the distance formula now. Let's take distance and midpoint, because we can get two of these. So there's the distance and midpoint formulas. Let's go and get the graph here. Okay, now it's a little bit different now, isn't it, this time? So because it's going down. So we're going from x1, y1 to x2, y2. Let's just say that this is that's x1. This here is x2. So we were going to make a triangle from this. Or maybe we should make it over here, right? No difference, but just make a right angle triangle from this. And this side up here is x2 minus x1. And this side here is y2 minus y1. And this side here is the distance. Now, how do we get the distance? Well, if we were just given any triangle, like if we were given a triangle like this with A, B, and C, then C squared is equal to A squared plus B squared is just Pythagoras theorem. So here, D squared is equal to x2 minus x1 squared plus y2 minus y1 squared. So it's just D is equal to is equal to the square root x2 minus x1 all squared plus y2 minus y1 all squared. Okay, great. So that's the distance formula is what I'm saying with all of that is a distance formula. It's just Pythagoras theorem. So this is just Pythagoras theorem given to us a different way. Okay, if we want to get the midpoint of the line, you see the midpoint of the line is the midpoint of the x's and the midpoint of this is the y's, right? So, and the and the midpoint of the of the y's, right? So this is like, how do we get that? Well, we just average x1 plus x2 over 2, y1 plus y2 over 2. Okay, so almost there. I'm not too sure if we use the distance of a point to a line formula here. I need to check quickly. Is that on the course? Sorry, I should know this already. Sorry. I just want to check if I've well, let's tackle it if we come to it, right? So we have a few more formulas. I'm just showing you a few of them to show where they come from. And you don't need to know where they come from, but I just want you to know they don't come from just from nowhere, right? That they make a lot of sense. Okay, so let's get into some questions then. Okay, so we want to first of all find the slope of the line through the points -2, 3, and 4, 15. So what we're going to do as we do these questions is we're going to do these in a couple of stages. The first thing that we're going to have to do is like sort of diagnose what kind of question is this and what equation, what tools do we need in order to basically sort of solve it, okay? So we're being asked about the slope of a line given like 2 points. So we go over here, we find this is our formula. So we have like, m is equal to y2 minus y1 over x2 minus x1. And you know what? I'm also going to go over and label in my question like this. And once I've done this labeling, this is usually enough to get you the low partial credit of 3 marks out of 10. Okay. Now you could say, well, how do I know it's x1, y1 first? And what could I not call it like x2, y2 first, and then x1, y1? The answer, no difference. Why? Because all you would do by doing that would be change the sign on the top, change the sign on the bottom, and then they would cancel. So it doesn't matter which one you choose to be, but you cannot go x1, y2, and you can't mix them. You just choose this to be point number 1, this to be point number 2, and then continue. Okay, so we've diagnosed the problem correctly. And we've already, kind of thrown in a kind of a number. So we've gotten to our low partial credit. So now what we're going to do is just be methodical. So what we're doing now is like no more thinking. So we've had to do all the thinking that was required for this question. Now we just have to be robotic and just go through the question in a methodical kind of way. So it's going to be y2, which is 15, minus y1, which is 3, over x2, which is 4, minus x1, which is minus 2. So that's going to be 12. 4 minus 2 is 4 plus 2. And then that's going to be 12 over 6. That's going to be a 2. So the slope of the line through -2, 3, and 4, 15 is equal to 2. Brilliant. Now we're going to have to find the distance and midpoint of these two. So what are the formulas that we're going to need? Distance and midpoint. We go over here, we find them. And now I'm going to bring them across. Bring them over here. Okay. Now, so I've diagnosed, I know what formulas I need. I'm kind of ready to go. So why don't I go over and just start labeling stuff? X1, Y1, X2, Y2. And why don't I say the distance, we'll call it d, is equal to square root of x2. So it's going to be the first part squared and then the second part squared. Okay. X2 minus x1. So 3 minus minus 1 is 3 plus 1. And then 10 minus, so y2 minus y1, 10 minus 2. So 10 minus 2. So that's going to be the square root of 4 squared plus 8 squared. And that's going to be the square root of 16 plus 64 is going to be the square root of 70, square root of 80, right? So this is going to be, well, it's going to be 4, the square root of 4 times square root of 20, which is going to be 2 times the square root of 20. So that's 2 times the square root of 4 times the square root of 5. So that's going to be 2 times 2 times the square root of 5. So that's going to be 4 times the square root of 5. Okay. And we'll just leave it like that because we prefer to write our answer in this form rather than working out kind of decimals. Don't work out any decimals unless you're told to write it in decimals. And then if you're told to write it in decimals, always look to see how many decimal places they want, and don't round too early, right? So you may be asked to do the answer to 4 decimal places, and then you've actually rounded to 2 decimal places in the middle of the question, right? So okay, so find the equation of the line through with slope 2 through equation 0, 3. And if we go back and we look down for equation of a line formula, we're going to need this one here. So far these questions have been pretty straightforward, right? Like they've just been, you're asked a question, you have to go recover the formula, and then we're just going to say, well, you know what, m is equal to 2, and then like x1, y1. So now I have y minus y1 is y minus 3 is equal to m, which is 2 times x minus 0. So y minus 3 is equal to 2x. So y is equal to 2x plus 3. And if we were interested in graphing it, so you've got y on its own on one side. So this is now in the form y is equal to mx plus c. So m is equal to 2, c is equal to 3. So we have a 1, 2, 3. And then we have like going through the point 3, and then with a slope of 2. So like this. Okay, something like that. It doesn't, just give you some kind of idea of it. Yes. Now, for this question here, having written down like this or this would already be like probably 3 marks out of 10 type thing, or having like written the equation of the line and having put 1 in, maybe that's 3 marks out of 10, right? And then having filled everything in would be like 7 marks out of 10, and then just getting down to the final form would be your full marks there. Okay, so find the equation of the line. So here, like y minus y1 is equal to m times x minus x1. Same one again. And then this is going to be x1, y1. This is going to be my m. So this is going to be y minus 5 is equal to minus 1/2. And then x minus 2. So that's y minus 5 is equal to minus 1/2 x. And then minus 2 is like a plus 1. And then this gives me a y is equal to minus 1/2 x, and then a plus 6. And then this is my m, and this is my c. And so if we wanted to graph that, well, 1, 2, 3, 4, 5, 6. So this is my 6 is my intercept, and then it's more like that. So remember, 1 is like 45 degrees, and minus 1 will be minus 45 degrees. So if something is less than 1, it's more shallow than 45 degrees. That's a way to kind of remember it. Okay. Okay, so I think this equation, I think I haven't done this fully. I think this must, oh yeah, I didn't actually finish this one off. I think it was like, sorry, I think we're saying like find the line that's perpendicular and that goes through the point 2, 3. So if we go ahead and graph this one, m is equal to 3, and C is equal to -2. So we go ahead and draw our XY axis, and we go to -1, -2, and then our slope here is 3. So this is like our, let me get a different color. This is like the slope of our line like this. Okay. And then we have the point like 2, 3. So let's say, I don't know where it is, but let's say it's here. So we need the line that goes like this. Now that line is going to, what's the equation of the line going to be? Y minus y1 is equal to y minus y1 is equal to m times x minus x1. So you see what I'm saying? Like what we have is like, we're asked to do this question, and asked to do the question is like, it's like a big unknown, right? And so what we're doing here in the first place is like, well, let's just sort of like not tackle the unknown yet. Let's just sort of scoot about this unknown, sort of orbiting the thing before we sort of tackle it. So the first thing is like, let's just draw a graph where we sort of put a point on and maybe where the 2, 3 is. And then we draw the line and we understand, yeah, this right angle, this is what we're going to be after. And then we want the equation of this line that's going to be, perpendicular to this one here. So let's write down the equation of a line formula. Okay, that's another thing. Like we're not really doing anything yet. But as we do these things, this unknown is getting smaller and smaller and smaller until it's just going to be one little thing that we have to realize. And then once we realize that, then we're going to be good. So this is like chipping away at a problem in a methodical type of way. It's like writing down what you know, okay? And already, by the way, like having drawn this diagram, 3 marks out of 10. And then come over here and it's like, let's we're going to be looking for this this equation of this line. So this is the formula, and then the 0.23 is on that line. So why don't we have y minus 3 is equal to m times x minus 2? And then if this is one of those questions which is like, like not only a low and high partial, but a mid partial. So like a 5, this might be enough to get you to 5 marks out of 10. Okay. So, yeah. Okay. Perfect. So, now the question really is, well, what is this m? And this is m of the second line, m of the first line. That's m of the first line. This is m of the first line is equal to 3, right? That one. M of the second line is, well, we don't know what it is. And actually, that's the unknown. That's the thing that we now have to tackle. So if we peel back all the layers, and the thing that we don't understand now is how to get this M2. However, we have perpendicular, we have like M1, we have M2. This should jog our memory. M1 times M2 is equal to -1. Well, M1 is equal to 3, which is the same as 3 over 1, which means that M2 has to be 1 over 3 minus, okay? So it's whatever that one is, flipped upside down with a minus sign, right? So now you have like, finally, y minus 3 is equal to -1/3 x minus 2. And this is y minus 3 is like -1/3 x, and then plus 2/3. And then you know what? Bring -1/3 x, and then plus 3 2/3, plus 2/3 plus 3, and then that's y is equal to -1/3. Sorry, y is equal to -1/3 x, and then plus 11 over 3. Okay. Okay, so now we're going to work out the area of a triangle, and a formula that we have for the area of a triangle is this one. Now, what you'll notice about this formula, so this is going to be the area of a triangle formula. What you'll notice about this formula is that in the formula, we just have an x1, x1, y1, and an x2, y2. We only have 2 points, but obviously a triangle has got 3 points. Okay, so let's even draw this triangle. So we've got the first point is 0, 0. It's here. Second point is like 1, 2, 3, 4. Well, let's not do that. Let's say 1, 2, 3, 4 is there. So this is 0, 0, 4, 0. And the next one is 4, 3. So 1, 2, 3, 1, 2, 3, 4. So it's like here. Okay. Now, this formula here, it only has 2 points because basically, even though a triangle will have 3 points, it only works if we have one of those points is the origin. Okay, so this is the point 4, 3. Now, one of the points is the origin, so I'm going to go ahead and call this one x1, y2, this one x2, y2, and now the area is going to be 1/2, and then sub in 4 times x1 times y2, 4 times 3, minus, and then 0, x2, which is going to be 4 times 0, and then that's going to be 1/2, and that's going to be 4 times 3 is 12, minus 4 times 0, so it's 12 minus 0 is just 12, and that's going to be 6. Okay, so the area of that triangle is going to be 6. Now, there's a few other ways that we could approach this problem. So let's imagine that we had the following situation. Let's say that this first point was not 0, 0. Let's say that this first point was actually 2 and 1. So let's say the first point was 2 and 1. So this x value was shifted by 2. So we would have to do that for this one here. The x value shifted by 2, and that one moved up for there. Okay, so that would have to be the second point. And then, so that would have to be 6, 1. And then for this one here, it would have to be also shifted by 2, but then shifted up by 1, so it would have to be here. That would be 6, 4. So imagine we were given this problem in the first way. Work out the area of a triangle with these vertices like this. What we'd have to do is we'd have to do the following. We would have to do this arrow where we would choose one of them, and normally you choose the one with the smallest numbers. And we just do an arrow going to 0, 0. And how do we get there? Well, we subtract 2 from the x and we subtract 1 from the y. And then we're going to do the same operation for the next two. So subtracting 2 from the x here will give me a 4. Subtracting 1 from the y will give me a 0. Subtracting 2 from the x will give me a 4, and subtracting 1. And then we get those 3 points. We ignore that first one, and then we just call this one x1, y1, and this one x2, y2. And then we sub it directly into the formula. However, let me just get this stuff here. This would work just as well if instead of doing that first one there, let's say we swap these around and we said that this one was this was the 6 here. Let me get my rubber. Okay, so let's say we had this one there, and then we moved that one to 0, 0. How would we do that? By subtracting 6 from that one and subtracting 1 from this one. This would bring this one to -4 and 0, and this would bring this one to 0 and 3. And now if we go ahead and call this my x1, y1, and this my x2, y2, and then we sub it into the same formula again, we're going to get the same answer again. So it doesn't matter which one you choose to put onto the side, it'll give you the same answer, right? You don't, okay, you just pick the smallest one, the closest one, because it involves the simplest sort of arithmetic. So that would be if we just finish this triangle picture. What we're doing, you see, is we're doing a translation like this of bringing the points. And you see, doing this translation like this, you see, it's like shifting. Imagine you had a triangular piece of cutout from a piece of paper on the table. You're sort of sliding it around the table. You're not changing the area of that thing. Okay, another thing is just to sort of look at it. you're going to have to be able to like look at stuff and just make sense of it. Because look, this here is a right angled triangle, and the base of it is 4 because you go from 0, 0 to 4, 0. And then this side here is 3. And then the area of a triangle is a half the base by the perpendicular height. So it's a half times 4 times 3, which is a half times 12, which is 6. A lot easier, right? So this formula here is working well when it's not like right angle triangles and stuff, right? That's when you really kind of need it. Okay. You wouldn't believe how many people make mistakes with some aspect of what I've been saying here. But then that's why this is a little bit more involved, this stuff. There's lots of little points like this that are easy to make a mistake with. Okay, so now here's another one. The intersection of lines. We have to find where two lines intersect. So let's sort of draw this first of all. Let's just sort of think about this first line. That number is m is equal to 2. And this number, c is equal to 1. So let's draw an xy axis. A 1, 2. And this is the line. Something like that. And then the other one is like, well, this time, m is equal to minus 1. And c is equal to 4. So that was 1. What did I say? C was equal to 1. Let's go back. Sorry. Okay, so this is 1, 2. Sorry about that. So this here is like, let me choose that color. That's more like that, right? And then this is like 1, 2, 3, 4. And then this is like second one. C is equal to 4. So the intercept is 4, so it's 1, 2, 3, 4. So it's up here. And then the slope it's minus 1. Sorry, not writing clearly. And so it's like this. And so we want the intersection point. So where do these lines cross over? Okay, now this question really it makes something kind of it gets across like the reason why we do coordinate geometry, right? So why are we doing coordinate geometry? Where was it? It was somewhere here. I had so what we're doing with coordinate geometry is we're basically turning pictures into numbers with equations and stuff, right? So here is if we draw these two lines, the intersection of the lines is the place where they cross over. And we can kind of see that it's probably somewhere in here, like maybe it could be 3 and, maybe that could be 2. Like we could guess at it, but we can't use the picture to get the number. The only way that we can get the exact coordinates of this point of intersection is to do algebra. Okay. So how am I going to do that? Well, what I'm going to do is I'm going to write down the two equations, 2x plus 1 and y is equal to minus x plus 4. And what I have here is called a simultaneous equation. It's an equation in two variables, x and y, and I have two of them. If you have an equation with just one variable in it, like x plus 2x is equal to 5x plus 7, you're going to be able to solve it. You're going to be able to get all the x's onto one side, and you're going to be able to get all the numbers onto the other and then solve it. Even if it's quadratic or something, you could also solve it. But as soon as we have an equation, maybe this is like x plus 2y is equal to 7, we're not able to solve it anymore, right? Because, x could be 1 and y could be 3, or x could be 2 and y could be 2, right? So, so we have an equation in two unknowns, but then we have a second equation in two unknowns. And because we've got two equations in two unknowns, then we're going to be able to solve it. Now, how do we solve it? Well, let's just sort of like look at what it says. See, it says y is equal to 2x plus 1. And when they cross over, right, then for the other line, that's also going to be true. So we can look at the other line, and you see that y, when they cross over, we can say, well, we can put this in that's 2x plus 1, you see, is then equal to the minus x like plus 4. So now I'm going to bring all the x's to one side. So I've got 2x, and that becomes a plus x. And then I have a 3 that comes over, and then I have an x is equal to, sorry, a 3x is equal to 3, and then I have an x is equal to 1. And then what I can do is, well, if x is equal to 1, that would mean that y was equal to 2 times 1. I just sub it in. It doesn't matter which one we do. 2 times 1 is equal to 3. So this is x is equal to 1, y is equal to 3. This is 1, 3. So this is the point 1, 3, which is the point of intersection of the two lines. So we can see that intersection is basically meaning where the lines in the picture cross over, but also we can see it as a solution to the simultaneous equation. And we can sort of say, like when they cross over, they're equal. So the lines are equal to each other. So whatever y is in one is what y is in the other, which allows us to do this sort of crucial step here. Okay. So doing something like, I don't know, doing something like this might be 3 out of 10 sort of thing for just doing a little bit on the graph. Then like, maybe getting this line here would be 7 out of 10, something like that. Okay. So maybe take a few minutes to have a go with some of these questions here. So find the slope. And what I want you to be doing when you're doing these questions is go through and start labeling stuff. So maybe I'll just do that just to get you started. So this is like x1, y1. This is like x2, y2. This is like x1, y1. This is like x2, y2. This is like x1, y1. This is like x2, y2. This is like x1, y1. This is m. This is a little bit more involved because this is like x1, y1. This is x2, y2. And we're not going to just be able to sub directly into a formula to get the equation of a line. We're going to need two formulas for this one, which is why this one is a little bit more challenging. So in each case, when you do these things, you're going to have to retrieve the correct formula from your formula book, from your book, whatever. And then you're going to have to, not that one, sorry. Then you're going to have to, after just fill in that formula, and then you don't have to work it out to the end. So maybe just take a couple of minutes to do that. Okay, so slope formula, m is equal to, I'll do it in a different color. Second. So m is equal to y2 minus y1 over x2 minus x1. So we'll just sub it in. So we'll put in 6. That will be 6 minus 2 over 5 minus 3, which will be 5 plus 3. So that'll be 4 over 8, which will be 1 over 2. The midpoint formula will be like x1 plus x2 over 2 and y1 plus y2 over 2, which is going to be 2 plus 8 over 2. And then minus 1 plus 7 over 2. So that'll be 10 over 2. And then 6 over 2. So that'll be 5, 3. Distance formula. So the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared, which will be then the square root of, let's say, x2, which is minus 6 minus 0 all squared, plus 8 minus 0 all squared. So that's going to be the square root of 6 squared plus 8 squared, which ends up being equal to 10. Okay, slope formula y minus y1 is equal to m times x minus x1. This is going to be y minus y1, y minus 5, 3 times x minus 4. Then just multiply out, finish everything off. And the last one, we need two formulas. We need m is equal to y2 minus y1 over x2 minus x1. And then it's going to be also that y minus y1 is equal to m times x minus x1. Okay, so we'd have to, first of all, and this is how these questions get more tricky, because, you know, you look at this and you're like, there is no formula for this. So that's where we have to realize, well, in order to use the formula, we need that. And in order to get that, we need that. And then it might go back even a couple more steps. In order to get that, we need that. And that's what we're kind of seeing when we're doing more and more examples. Okay. Okay, so some of the harder questions, the perpendicular line, we already did a bit of a quiz there. So let me get now into exam questions for the last 15 minutes. And what we're going to see with the exam questions is something that's sort of similar to what we've already kind of done. Oh, that one's duplicated. Except with a kind of a twist. Okay, so we'll kind of like see them and we'll be like maybe having the feeling that like we've never seen anything like this before. Okay, so we want to first of all show that the point 4,1 lies on L. Now, if the point 4,1 lies on L, then this would be my x1, this would be my y1, and I would be able to sub these into the equation and get like equality, right? Like find, like, if I ended up subbing this into the equation and the left hand side ended up being equal to 2 and the right hand side ended up being equal to 3, then it wouldn't be on the line. But if it ends up being the same on both sides and I haven't gotten some like if I put a point in that isn't on the line and I end up getting some kind of bogus statement like 1 is equal to 2, that's maths telling us that it's not on the line. But that's the way that maths can communicate that to us. Okay, so what we're going to do is just sub it in. So a mistake you might make is just because it's going left to right, you could put the 4 in here first, but of course it's the 1 that goes in there, and then a half times like 4 minus 1, and then that's going to be 1 is equal to a half times 4 is equal to 2 minus 1, and then that's 1 is equal to 1, and that's true. So these weren't really equal signs. These were sort of like equal, you know, where is it equal? But now that we've arrived with a statement, that means that 4,1 is on the line. So it says draw the line L on the diagram below in the domain minus 4 x. Sorry, x is greater than minus 4, x is less than 5. So we already have what do we have? So we have 4,1 is on the line. and we have that m is equal to a half, and we have c is equal to -1. So we have that the y-intercept is here, and we also have that the point 4, 1 lies on L. And so we're going to draw this now. We're going to draw it in the domain. Sorry. So we had to draw it. It's this business of again. Okay. Yeah. So this is, let's just have a look quickly about what we mean here. So in the domain -4 less than, so what we're saying is that we're going to draw this basically for basically x starting at -4 and going up to 5. So what we have it is inside of that box. That's what we're going to draw. Obviously, the line can go further and all that sort of stuff, but we're not doing that. We're going to just draw it in that domain. Okay, so the domain you can kind of think about a kind of a domain is like a place or something, right? So, but it's in maths, the domain will be given by like x goes from here up to here, y goes from, you know, like, well, y would be the range, but this is just like, I mean by that maths, the terminology in maths can be quite off-putting, but that's just what we mean. All we mean is like basically inside of this box. Okay. Good. So let's have a look at the so this here was this question had 15 marks, and they were combined together. So what's low partial credit? A work of merit, for example, some correct substitution in 1. So if I had put in like a 4 for the x here, right? If I put in a 4 here, that wouldn't have been correct. But if I put in a 1 here and I didn't do anything else, I'd get 4 marks out of 10, 4 marks out of 15. Okay, so not quite to the level of a pass on it, right? Or 2, any work, or sorry, basically effort at getting a point. So even saying, for example, like C is equal to -1. If I had said that, that would be effort at getting a point. So if I'd done C is equal to -1, if I'd done this and then subbed in like just that, that would be a work of merit in part 1 and part 2. And then I would get 6 marks out of 15 just for that. Oh, sorry, for the mid-partial credit, that would be 4 marks out for getting either. For getting both, then it would be 6 marks. And then for 8 marks out of 10, then it would have to be 1 part correct. So it'd have to get 1 part correct and then something good in the second part, okay? And then the last one is like, if you were to draw this line without doing with a ruler and it was all kind of buckety, you would lose 1 mark out of 15 for doing that. Okay. The line K has the following solution, has the following equation where x and y are elements of OR. Line K intersects the y-axis at the point where x is equal to 0 and use this equation to find the coordinates of the point Q. So what they're saying is if this is the line, this is the x and y-axis. Imagine that's the line. They want us to find that. Now, how do we find that? Well, if we had our line as y is equal to mx plus c, then we'd be able to get that c, you know, and do it out. So we're going to do this in one of 2 ways. The first way is just to get y on its own on one side so that we can have it in this form. So, okay, this is y. What's not belonging on the left-hand side? Well, this bit and this bit. So y is equal to -2x and then a +4. So this here is the y-intercept. So this is 4 for the y, but it's obviously 0 for the x because it's on the y-axis, and this is like 5, 4, 3, 2, 1, 0. So 0 for x means that you're on the y-axis. So it's always just true that like if you're on the y-axis that your x is 0. So this is 0, 4. But another way to get this would be just to sub in, well, if, you know, we want to find intersects with the y-axis where x is equal to 0, we say, okay, well, x is equal to 0. So that means that 2 times 0, we just sub it in, plus y -4. And that's to get, you know, That's y minus 4 is equal to 0. So that's y is equal to 4. So that's another way to get like 0 for the x, 4. That's another way to get it. Okay, so this is worth 10 marks. And then so this is how you do it. This is how they use the second method to do it. So work of merit, for example, substitute 0 in for x. So if you just did this bit and only that bit, you would get 4 marks out of 10. So you get a pass. And then for the high partial credit, you write it in the form y is equal to mx plus c. And then you get, if we did this, and then we got c is equal to 4, then we would get the high partial credit, which would be 5 marks out of 10. The line K intersects the x-axis at the point 2, 0. So there's the point 2, 0, okay? And it says plot and label both the points P and Q. So from the last example, Q is equal to 4. Q is equal to 0, 4. Oh, incidentally, if we'd written down 4, 0, I just read that, then you would they'd kind of go, look, you had it right, but we're just going to take 1 mark off for having done that. So you get 9 marks out of 10. But 0, 4 is up here. Okay. And it says, hence draw the line K. So, let's just go ahead and do that. Okay. So we just do something like, no, that's not right. Something like that, right? Okay. Now there are obviously, trickier types of examples, but I'm just sort of. Okay, so we go on with this point, this question now, right? So we're like, okay, now we're going to say, so we have this picture from before, and so just the rule basically is that if you're doing a question and you have A, B, C, and D for a question, that usually means that they're separate parts of the question. But if you have A part 1, A part or AI, then they're all connected to each other. So this one is II, and this next one is III, which so this next one is a continuation of the previous one in this case. So this is what we had for the previous one. Let's see what we have for this one. So O is the point 0, 0, and OR is the point that makes OPQ or a parallelogram. And draw the parallelogram OP on the diagram on the previous page and write down the coordinates of the point OR. So let's just add the extra point. Now, so this is the extra point. And what I realize is, like, in order to get the parallelogram, I'm going to have to say, well, how am I getting from like here to here? So if I'm going from there to there, I'm going from the point 2, 0 to the point 0, 0, right? And what is that for like a movement, right? What is that movement? Well, it's a -2 for the x and a nothing for the y, right? So I'm going to do that same thing for this point. So that's going to take the point 4, 0, and then I'm going to translate it. It's a -2 for the x and a 0. So this ends up giving us, sorry, I made the same mistake I chastised you for potentially making. So the point 0, 4. And we're going to move that a -2 for the x and a 0 for the y. And then that's a -2 and a 4. So that's like 1, 2, 3, 4. And we're over to here. Okay. And then that's the thing there, like that. Okay. And now what we're going to do is just sort of, so now we've drawn it, and that would be the point, like, -2 and 4. Okay. But we could get there as well by saying, okay, like, that point there is like 2, 0, and I want to get to, 0, 4. So how do I get from 2, 0 to 0, 4? Well, I subtract a 2 from the x and I add a 4 to the y. So now if I was to start with 0, 0, I subtract 2 from the x, I get a -2, and I add a 4 to the y, I get a 4. So it doesn't matter which way you do it. It's just that all the sides in the parallel, this side here, parallel to this side here. this side here is parallel to this side here. So whatever we do in getting from this point to this point is the same as what we would do going from that point to that point. So what are the coordinates at that point there? -2 and 4. And so we have to have, so to get the marks here, we would have to basically, if we just plot P and Q correctly, we're already getting like 3 marks out of 5, right? But we, yeah, so you just have to get those two plotted correctly, and then that will be enough to get you 3 marks out of 5, and then to 5 marks out of 5, you'd have to have those other two. And then if we did the pilot diagram, like if we sort of drew a diagram where we sort of had a or over here somewhere, but it wasn't exactly in the right spot, we could still get the low partial credit. Or if you plot or correctly, so if you put or into the right thing, but you don't write down the coordinate properly, then you get a high partial credit. Okay. So this is the last one we'll do. And then we'll call it a day. So find the area of the triangle with vertices at the following points. Okay, so the points here are 2, 0, 2, 4, -3, 3. The formula we want to use is the area of a triangle formula, x1, y2 minus x2, y1. So I'm just going to write that down straight from here. Okay, so what I need to do is just sort of go through and say, let me just write down all the points. 2, 0, 2, 4, and like -3, 3. And I'm going to move one of these points to 0, 0. And I'm going to choose the first one because it's the one that's already needs the least done to it in order to get to 0, 0. Okay, so that's going to be like a -2 on the x and there's nothing on the y. So doing that there, I'll have a 0, 4, and then I'll have a -5 because we're just going down from -3 and a 3. Okay, and then from